far from being destructive, inside the nuclear furnace of every star, there is an extraordinary process of creation.
As I stand here in the bottom of this silo and look up at the thermonuclear device 100 feet above me, if it were to go off, in an instant, I and everything in a 10-mile radius would be evaporated. But in that same instant, it's quite likely that almost every element in the universe would be created. Just as inside stars, hydrogen fuses to form helium, which fuses to form carbon, then nitrogen, then oxygen, silicon, iron. So that as I look around me here, everything I see was once inside of a star. Every atom came from inside of a star.
The universe began with hydrogen. And hydrogen created the stars. And the stars created the elements we need for life. Oxygen in the air, calcium in our bones. It all came from the stars. But how? If it was created there, how did it make our world?
It's astonishing to think that all the ingredients to make the Earth and every living thing were created inside stars. Every star is an immense factory churning out billions and billions of tons of chemicals. But the chemicals aren't much use to anybody while they're in there. Luckily for us, stars don't last forever. Just occasionally, they explode.
Amazing, but true. Entire stars can blow themselves apart. To understand why, let me take you back to the very last few moments of a star's life, just as it teeters on the point of destruction. This is a star that died billions of years ago. It's huge. Its life has been violent and short. And its death made our lives possible. You are about to witness one of the most violent and wondrous events in the cosmos. The star has run out of hydrogen fuel. The nuclear fires that have kept it burning for millions of years have gone out. As it cools, it shrinks. It starts to collapse under its own weight. It crashes inwards and explodes. The whole event is over in 1,000th of a second. They call it a supernova, an explosion so bright it outshines entire galaxies. Billions of tons of star stuff hurtle outwards into space. So look at a supernova, and you're witnessing a moment of creation. But even with our most powerful telescopes, these awesome explosions remain frustratingly distant. The best way to find out what really happens when a star dies is up close and personal.
We are now charging. Access for the charger shot. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
To understand the moment of creation that happens when a star dies, You have to study the explosion.
So we really are mistimed by 2 nanoseconds.
Yes, we are.
Paul Drake's job is to recreate the most violent explosion in the universe in a lab in upstate New York.
It may not look like it, but this is our version of an exploding star in the lab. Now, exploding stars release a huge amount of energy, and we can't do that here on Earth. We'd blow up the solar system. But what we can do is concentrate a great deal of energy into a small volume.
To generate anywhere near the force of a supernova, Drake uses the world's most powerful laser and focuses it onto a point smaller than the head of a pin.
So here we are in the laser bay. This is where the big laser meets the tiny target. We wear these bunny suits out here. They're to protect the laser, and we wear glasses. That protects our eyes from the laser. The laser's in the building right next to us, or the room right next to us, is the size of a football field. It's huge. The energy in that laser beam is 20 times the amount of electrical energy flowing throughout the entire United States at any one time.
The target is a tiny tube containing the same materials you'd find at the heart of a star.
When the laser hits this target, that creates a shock wave that's so strong that it shreds the material inside that tube. It tears the atoms apart.
Inside the tiny target is Paul Drake's version of a star just before it explodes. The inside of a dying star is made up of layers, like the layers of an onion. The outer layers are the last remnants of the gases that once fueled the star, mostly hydrogen. Deeper, there are layers of calcium, sulfur, carbon, and at its heart, a dense core of molten iron. Drake's tiny target is packed with these same layers. It's like a slice through a star. His aim is to see what happens when a star explodes. Here, slowed down millions of times, is what his experiment reveals. The complex patterns of an exploding star shown in astonishing detail. The beautiful and precise motions that scatter the building blocks of life out into space.
That explosion of the star throws the elements that were formed in the star outwards. They go outwards into the galaxy, and some of them gather together and form other stars, solar systems, even planets like the Earth.
These images, captured by our most powerful telescopes, show the remains of these violent events. Vast clouds of star stuff expanding through space, one of the most breathtaking sights in the universe. But there's a puzzle in these pictures. It may be the stuff of life, but these are just clouds.